Hello, this is Mrs. Ward, and I am going to go over the 4.1 to 4.3 review worksheet. So let's begin. So we're going all the way back to 4.1, which is when we first met, and we're trying to sketch the angle in standard position. Our angle that they give us is a negative over 3. So I can either count or I can find the coterminal angle because we know what a coterminal angle is now. But I'm just going to count. So so if I'm thinking of my unit circle, I know that this would be about 1 pi over 3, and this would be about 2 pi over 3. So I'm going to sketch my terminal side. Here's my initial side. My initial side is always the positive x-axis, and then I'm going to show my angle of rotation. It's going down because that angle is negative. And then it says convert the angle to degrees, and by non-calculator it means that I want to have an exact answer or leave the pi in it depending on which way I'm going. But you can use your calculator to help you if you need. So I'm going to have negative 2 pi over 3. To convert it to degrees, I'm going to have the pi in the denominator, the 180 degrees in the numerator. And the reason why I do this is that I can see that the units of pi will simplify. And when I multiply straight across, I end up getting a negative 120 degrees. Letter C says find one positive, one negative coterminal. Remember coterminal angle, you're going to add or subtract 2 pi if it's in radians, or add or subtract 360 if it's in degrees. So let's start with negative 2 pi over 3. I'm going to add a positive 2 pi. And remember, I can do this in my calculator and do negative 2/3 plus 2, leave the pi out of it, and then bring the pi back at the end. And when I do that, I get 4 pi over 3. That's positive, so that I'm going to use my positive coterminal angle. Then to find the negative coterminal angle, I'm going to do negative 2 pi over 3, and I'm going to subtract 2 pi, negative 2/3 2. And your calculator will give you negative 8/3. You just have to remember to put the pi back into it. So my negative answer is going to be, if possible, the complement and supplement of 2 pi over 3, and we changed it to positive. So if I go to do the complement, it's in radians, so I would start with pi over 2 minus 2 pi over 3, and that's a minus sign. And when I do that, I would get a negative pi over 6. Well, as soon as this angle comes out as negative, I'm going to say that that's not possible because it has to be two positive angles. I'm going to say not possible for the complementary angle. To find the supplementary angle, I'm going to do pi minus 2 pi over 3. And when I subtract that, I get pi over 3. So the supplementary angle is pi over 3. Evaluate using a calculator, round to 3. So I'm just doing this on my calculator. Sine of 66 degrees. Hold on, let's actually bring out the. Okay, so I have my calculator out. I added a calculating page, and I'm going to do the secant. So I'm going to hit trig, secant of 66, and then I have to remember to hit degrees. Right now, I'll do a quick check. Your calculator should be in radians. When I put this degree symbol in, it tells me to use degrees, and I get 2.54. Now I'm going to do the sine of 14 degrees, 14, getting the degree symbol, and when I hit enter, I get 0.242. We're going to round to 3 decimal places. So this would be 2.459 actually. Cosine of a negative 1.3, and I'm going to get 2.67, 2.67, 3 decimals, I'm good. And then cotangent, and then I'm going to use my control divide, my favorite button, and I'm going to do 11 pi, 11, getting my pi, remember pi's down there, and then over 9. And I hit enter. So those are my answers. So I just page over here. And so just to show the correct rounding, this would be 2.459. The sine of 14 would be 0.242. The cosine of negative 1.3 would be 0.267. And the cotangent of 11 pi would be 1.192. So that's the correct rounding for those two. All right, moving on. Number 3, finding. We will give you a blank unit circle. You're going to have to fill that in. So if I'm looking at the pi over 6, the order pair that goes with pi over 6 is the square root of 3 over 2, 1/2. This question is just asking for the sign. The sign is the y value, so I'm just going to write 1/2. Cotangent of 150 degrees. The order pair for that is negative square root of 3 over 2, 1/2. The cotangent is going to be the cosine, which is the x value, over the sine value. And when I do that, I get a negative square root of 3. Remember, a quick way of simplifying these is the denominators will go away, and I don't have to rationalize, so that's kind of nice. All right, doing the next one, cosecant of 60 degrees. The order pair that goes with 6 is negative, no, I'm sorry, positive 1/2 square root of 3 over 2. Cosecant is 1 over sine. So I'm looking at the sine, which is the square root of 3 over 2. I'm taking the reciprocal of that, so I'm going to start with 2 over the square root of 3. When I rationalize it, I end up with 2 square roots of 3 over 3. Remember to rationalize. You're multiplying by the square root of 3 over the square root of 3. Now to do the cosine of 5 pi over 4, the order pair for 5 pi over 4 is negative square root of 2 over 2, negative square root of 2 over 2. The cosine is the x value, so negative square root of 2 over 2. Of 2 pi, the order pair that goes with 2 pi is 1, 0. Tangent is the sine over the cosine. So in this case, that would be 0 over 1. Well, that will just end up being 0. And then 4 says find the point on the unit circle that corresponds to the negative. So I'm going to take 7 pi over 6. I'm going to find the coterminal angle, so I'm going to add 2 pi. And when I do that, I end up with 5 pi over 6. I know that 5 pi over 6 is in the second quadrant, which means my x is going to be negative. So this will be a negative square root of 3 over 2. And the y will be positive, so a positive 1/2. And I knew as soon as it had a denominator 6, it would be these numbers. I just needed to figure out which one was positive, which one was negative. Number 5 gives me a triangle. They give me the, remember, here's my right angle. Here's the hypotenuse, which is 61. I need to find this missing side here. Let's just call that B. So I'm going to start with the Pythagorean theorem and say B squared plus 60 squared is equal to 61 squared. Of all that, I end up getting x squared is equal, or b squared, sorry, is equal to 121. So b is equal to 11. So this missing side is now 11. To find the sine, remember I'm looking from this angle, so I'm going to do the opposite over hypotenuse, which is going to be 60 over 61. The cosecant is a reciprocal, so I'm going back here and just flipping it, so 61 over 60. The cosine is the adjacent, so it's the side that helps form this angle, so 11 over the hypotenuse, which is 61. The secant is a reciprocal, so I'm going to just flip the 11 61s and make it 61 over 11. The tangent is the opposite over the adjacent, so this will be 60 over 11. And then the cotangent will be the reciprocal of that, which is 11 over 60. So that's my number 6 asks me a picture. It's at the 12 meters. That's the shadow. Here's the shadow. Remember, shadow lays on the ground. The angle of elevation to the top of the flagpole, so looking up to the top of the flagpole, is 35 degrees. And remember, this is my shadow. And this is what I'm looking for. So I have the adjacent side to this angle, and I have the opposite side. The trig function that deals with opposite and adjacent is tangent. So I'm going to say the tangent of 35 degrees is equal to the opposite over adjacent. Whoopsie. Adjacent. Now this one, my variable is in the denominator, so technically I'm multiplying both sides of the equation by x. So that I can simplify this, and I'll get 12 is equal to x times the tangent of 35 degrees. To solve for x, I'm going to divide both sides by the tangent of 35 degrees. That's really messy, and I'm really sorry. So on my calculator, I'm taking 12 divided by the tangent of 35 degrees. And when I do that, I get my height should be, the length of my shadow to be 17.138 feet, going to 3 decimals. So I could write the shadow is 17.138 feet long. Okay, find the radian measure of essential angle of a circle with a radius of 10 that intercepts the arc length of 12. We will give you that formula of S is equal to R times theta. That's the formula we use for arc length. Remember, the S stands for the arc length. So if I have this angle, the S is the side on the outside. This theta is the angle that's inside. And remember, that always has to be in radians. And then R is the radius of that circle. So I'm going to fill in what I know. It says it wants me to find the radian, the measure of the central angle, has a radius of 10 and an arc length of 12. So to find theta, I'm going to divide both sides by 10. Putting in lowest terms, I get 6/5 is equal to theta. This is my angle that I'm looking for, so my final answer will be 6/5 radians. My angles are always in radians. Remember, you can't just throw a pi in there because you should hear the word radians. It's just 6/5. Give one solution of the equation. So I want to know when the cosine is equal to -1/2. So thinking on my unit circle, I want -1/2, and then the other ordered pair that would go with it would be the square root of 3/2. So the cosine is negative in the second quadrant. So I'm going to do the radian first. So this would be 2 pi over 3. That would be my radian. Again, I'm looking at my unit circle, and that would be 120 degrees. The cosine is also negative in the fourth quadrant, and that would be the ordered pair -1/2, negative square root of 3/2. And in the fourth quadrant, that would be 4 pi over 3, and the degrees for that would be 240. Either one is fine. Either one is fine. You don't have to give both, but I gave you options there. Okay, number 9 says use trig identities to transform the one side of the equation to the other side. Remember, I have this equal sign, which is like a barrier. I can't add, subtract, multiply, or divide anything to both sides. So my first strategy, since I'm not multiplying and nothing is squared, is I'm going to rewrite everything in terms of sine and cosine. So cotangent is the cosine of theta over the sine of theta. And then sine of theta is already in terms of sine or cosine, so I'm just going to write sine of theta. And I'm going to put that over 1 so I can see what I'm doing more easily. And then I'm trying to show that that is equal to the cosine of theta. Well, when I write cotangent, I can very simply see that the signs will simplify because I have one in the numerator, one in the denominator. So I'm left with cosine of theta is equal to cosine of theta. And that's it. I'm done. I've transformed the left side to look like the right side. Okay, number 10, it says the cosine is equal to 0.74, and it's in quadrant 1. Well, quadrant 1 tells me that everything, remember, all students take calculus, so everything is going to be positive in the first quadrant. So the cosine is 0.74. They want me to find the sine and the tangent. I'm going to use a trig identity. I'm going to use the fact that sine squared theta plus cosine squared theta is equal to 1. That's the main trig identity that I should know. And then, so then I'm going to have sine squared theta plus cosine is 0.74 squared is equal to 1. When I square that, and I'm going to go step by step to show you what you'll get, I will get 0.5476. I'm just going to leave in my calculator. To find sine squared, I'm going to subtract this 0.5476 from both sides. So I'm subtracting that. And when I subtract, I end up with 0.4524, 0.25. Now to solve for sine, because this is sine squared right now, I'm going to take the square root of the left side, which means I'm going to take the square root of the right side. So I'm going to have the sine of theta is equal to, and taking the square root, you get plus or minus 0.6726. But going back up to the first equation, it tells me that I'm in quadrant 1, which means that the sign has to be positive. So I'm just going to give the positive answer of 0.6726. Oh, 3 decimals. 0.673. Now to find the tangent, I'm going to say the tangent of theta is equal to the sine over the cosine. Well, the sine we just said was 0.673. The cosine is 0.74. When I divide that on my calculator, I get 0.909. And that will be my tangent. Again, I'm making a positive. 2 reasons why I'm making a positive. First of all, both my sine and my cosine were positive. So when I divide a positive by a positive, I'm going to get a positive. And the second reason is if this angle's in the first quadrant, everything has to be positive, including that tangent as well. So just double check those. Number 11, you're asked to draw a triangle, and it tells you that your cosecant, which is the reciprocal, so my cosecant is 29 over 21, and I know that my sine is the reciprocal of that, so that's going to be 21/29. So what they're telling me is that the sine is positive and the tangent is negative. So going back to that, all students take calculus. As soon as they tell me that the tangent is negative, that eliminates the first quadrant. And then the sine is now positive in the second quadrant. So when I go to draw this angle, I'm going to put a point here, just put it somewhere. To draw a proper trig triangle, I start at the origin. I draw a line to that dot that I just put in the second quadrant somewhere, and then I drop a leg down to the x-axis. I'm always using the x-axis as my adjacent side. Here's my angle. So my sine is the opposite, 21, over the hypotenuse, which is 29. Just a reminder, the hypotenuse is always positive. So if this happened to be like a negative 21 over 29, the negative sign would go with the 21 because the hypotenuse always has to be positive. All right, now I need to find my missing side. So I'm going to call this x. So I'm going to say 21 squared plus x squared is equal to 29 squared. And when I do all that, I end up getting x to equal 20, well, plus or minus 20 because I took the square root. But since I'm moving to the left, I'm going to make that a negative 20 because my x value would be negative. So my cosine is going to be a negative 20 over 29, adjacent over hypotenuse. Secant is going to be the reciprocal of that. So the reciprocal of a negative number is still going to be negative. So I'm going to have 29 over 20. The tangent is going to be the opposite over the adjacent, so 21 over negative 20, and then the cotangent is going to be the reciprocal, so negative 20 over 21. Again, it doesn't matter where you put that negative sign as long as you have it there somewhere. And then the last couple on the review worksheets are, and we'll have these on the test, are questions that are similar to what you would see on a standardized test that are dealing with what we've been talking about. So if the angle if the tangent of an angle is negative and its secant is positive, which quadrant does the angle terminate? So again, this is going back to all students take calculus. So they're telling me that the tangent is negative. As soon as they tell me that the tangent is negative, that eliminates the first quadrant because everything's positive in the first quadrant, and eliminates the third quadrant because the tangent is positive in the third quadrant. The secant, remember the secant is 1 over the cosine. So if the secant's positive, that means the cosine is also positive. Well, the cosine is positive here in this quadrant down here, which is the fourth quadrant. So my correct choice is going to be the letter D. 13, in a unit circle shown at the right, what are the coordinates of B? So they're telling you that this is 30 degrees. So the ordered pair that goes with 30 degrees is the square root of 3 over 2, 1/2. First quadrant, everything's positive. So the one that corresponds to that is going to be the letter B, and that would be the correct choice. 14, consider the right triangle with an acute inner angle theta. So I'm going to draw a right triangle. I'm going to have this angle theta. If the cosine is 3/5, adjacent 3, hypotenuse 5, and the sine is 4/5, so the opposite would be 4, the hypotenuse is 5, what is the tangent? The tangent is opposite over adjacent, so it's going to be 4/3. If you didn't want to draw the triangle, if you had the tangent theta, remember that's sine over cosine. So I could have put 4/5 over the cosine, which they told me is 3/5. Remember, a quick way to do these is the denominator will simplify, and I'm left with 4/3. So either way, I'm getting choice D, which is 4/3. Okay, I hope this review helps, and we will see you next time in class.